Hello, Internet. It's 3 o'clock, so that means it's time to rock out with your favorite uh, librarians named Moacir and Alex who work at in digital scholarship of Columbia University Libraries. Alex will be on screen presently. In the meantime, I'm Moacir Pita Sapareta. I'm the research data librarian. I'm here to walk you through the exciting world of the Rose Hall Project, part of the Studio Remote series of Twitch streams for your viewing pleasure and your learning about the wonderful world of what some people call digital humanities, what others call digital scholarship, and what I call just doing stuff on computers to bring knowledge to the world or something along those lines. On Tuesdays, I have a separate show called Coding with the Dead, where I am working by myself on a much more complicated project than this one. And that one's plodding along at about the pace it should be. And Alex is going to have a new show starting soon called How to Find Shit, I think. And we talked about that a little bit last week. He can maybe give, if he can manage to give a one sentence description of it, then I will let him do so as soon as I bring him on screen, which is ta-da right now. Can you introduce yourself, Alex? And
I am Alex Eve. I'm the Digital Scholarship Librarian at Columbia University. And now that I see my eyes, I've been looking at the screen since and Zoom meetings since like 8 in the morning, so they're a little red. I apologize for that. I promise you, no animals were hurt in the production of this show, nor drugs consumed. It's just fatigue from the eyes. So for the show, how to find SH asterisk T because we wouldn't use a bad word. Um, we are going to have different shows on different advanced techniques of research. The whole point is advanced techniques of research, not the writing part of research, the conceptual part of research, but the technical part of research. Like, what are things that you can do to find stuff that you will be using in your research? I think it's even implied in the word research, to search, to find, to search again, research. Get it?
all right, so we are on advanced states of empty today. uh,
Yes, this is
I
it's been quite a
too,
week.
I too. Alex earlier today was like, maybe we should cancel today, and I was too tired to write back to say, dude, there was a tweet already about it. We can't make Twitter out to be a place of lies.
Uh,
Um,
we could have
you know,
deleted that.
Putin doesn't pay us for that.
Nobody took a screenshot of that tweet.
I mean, I did because it added me. So I was like, oh, someone pays attention to me on the internet. I'm
Mm.
gonna take a picture and send it
We
to
own
my.
that Twitter account. We weren't supposed to tell people that. It's a mysterious organization account.
Just some mysterious Columbia lib data. Nobody knows. Nobody knows what it is. Nobody, it just shows up and starts tweeting, and people are saying that Columbia lib data is going to be on Twitch, and these guys are
I
going to be
guess
on Twitch.
like also for those of you who think the Columbia Library account is magic itself, I just want to disabuse everybody in the audience about
No,
that
wait,
too.
wait, 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 wait. Don't throw Abby under the bus. She has nothing to do with this. This is the Columbia Lib data account, not at Columbia Lib, which is a
It's all
magical,
magic.
is definitely a magical account, because it's run by the Magical Communications Office and not us goofuses in Research Data Services, which is who runs Columbia Lib data.
Good times.
Now I'm going to tell Abby you threw her under the bus.
It's Abby, everybody. It's Abby.
Actually, maybe that's not maybe that's like hidden information too. I don't know.
It's like it's us. He was behind the curtain all along.
Well, like the Columbia Lib account doesn't say in the bio like tweets by Abby, um, but that's because like she doesn't have Twitter herself.
Her own personal Twitter
Yeah,
account.
she sticks to Instagram, if I recall correctly. Am I doxing her? Oh crap!
Now people are gonna rush over to Insta to try to follow her.
Yeah. Oh, well.
All right, let's. Today we are gathered
Wait, wait,
here.
wait, 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 wait. How do we make the whole world use Git?
No, 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 no. We're not gonna spend an hour talking about how to make the world use it. No, no. This is the Rose Hole Project show, not the 1 hour of digression and then the Rose Hole Project show. Just because we did that the last 2 weeks, we're not doing it today. Today is gonna be 2 hours of the Rose Hole Project. But actually, since everybody's running on empty, I propose we work on this really good for 1 hour. Our audience will understand that this episode was a little shorter because we are visibly fatigued. I am destroyed after this week. For some reason, I ended up with a bunch of 8 a.m.s in the morning. And also I ended up working late at night because I have some deadlines creeping in. So.
Yeah, that very much describes my situation too. All week, I've been like garbage by 5 o'clock, and like gone to sleep at like 6 p.m. and then woken up at 10, incapable of falling back asleep, but also too tired to work.
And you saw already the preview of that project. It's, I mean, I'm done, but that was a lot of the last final touches this week on the Frontline Nurses project,
Oh,
which is going to be released in March, on March 10th. And it's another digital scholarship project done by our unit, and it's going to be great. That one is actually an archive of oral histories from nurses in Liberia and Sierra Leone during the Ebola, who were active at the front lines during the Ebola crisis. And we're going to publish it. And that's the first time we do an archive of oral histories on wax. So it's a little bit, tweaking of the wax to make it be amenable to oral histories. And we are, and then we're going to add COVID oral histories later next year. So in the end, it's going to be an archive that compares or allows you to experience the sort of lived experience of nurses across the Atlantic during two health crises that are that have a lot of similarities and differences. So it's very proud. It came out gorgeous. You'll see it. The world will see it in a couple of weeks.
are you still like? What is your take on the way the designers like the Figma life that you had to live?
Oh yeah, this was also the first time that I had to that I had to work with Figma as it was being run by a design company. So the original design was not by me or by us. I just had this was not, it was not the first time I implement somebody else's ideas, but this was the first time that I had to implement somebody else's ideas to perfection. Like usually I have worked with other people's, kind of creative suggestions, but they became more of like a guideline of like themes, or like connotations and things that I could then have a little freedom to interpret. But this one was the first time that I worked on somebody where like they paid, the team paid for a design company, a web design company, to design this a complete solution, and they use Figma, which then has a lot of it already has the CSS a little bit in it.
Mm-hmm.
It's still not, it's not the CSS, it's not the final CSS file. This is where Figma cheats a little because it's just snippets, that you copy and you still have to copy and paste them and reorganize them, add a lot of cement or in between the bricks for it to work. But in any case, I hated it. The actual work of working with Figma. I find it slow and cumbersome for what it is that we're trying to do. I would have preferred for them to send me, like drawings, and then just say like, do
This
this.
this is famous last words because the gallery project I was working on worked that way. It was the designer would send me drawings and like just have like arrows that are just like do this way. And the problem is that it's very hard for me um to implement like I couldn't extract the user experience out of the drawings.
I couldn't do this with Figma either, or at least these designers did not. I know that Figma allows you to build some fake interactivity, but
Yeah.
not the way these folks didn't do it. They were not
Okay.
using Figma that way. So I had to figure out a bunch of the stuff. Like, what do they mean? And it was like also like my favorite example is I did it exactly the way they asked me to, but like right now on the homepage, you're not able to see the hamburger menu because the way they passed it to me, there's a picture with a black background in it, and the burger menu is black too. And there is no indication in the Figma that I should add something to it or deduct anything from it. So it doesn't tell me also what happens when I scroll up and down or anything. So I'm just like, you know what? And they were, and in this particular crew in particular, it meant a lot to them that I respected their design. So I tried to do it as much as possible. It has the added advantage that when somebody later down the road says, well, hey, I can't see the hamburger menu, I can always say, well, I'm just the help. There's some brilliant designers who thought about this.
Rad. So I don't I feel bad about preemptively saying that we're just gonna do like an hour and then just topple over like completely spent, especially since I actually have another Zoom thing at 5. But I pre-warned the person 2 weeks ago that I would very likely be completely on empty. But I really do want to go, but I might just go and just be like, I might just have my camera off and just like Zoom from bed. And just be like, yeah, you can't see
yeah, we
me.
have our Jeremiah says also that he thinks 1 hour should be fine.
Where did he say this? Not in the stream.
Not on Twitch. He's talking on our work chat, on our regular work chat.
All right. But
so let's do it. But let's do a good hour.
Hold on. So this is what I was going to suggest. So we finished yesterday or last week. We finished talking about how Celia, Professor Naylor, was really into the idea of the wavy wedges.
Yeah.
So I thought, what?
Did you figure out something?
Have we had a show since then?
Correct. That is the right answer. That is very good. You get a name.
I can show you what was in my head at the end of the episode last week. And so my suggestion was that we try to today at least get wavy wedges. They will be overlapping each other, but then again, who knows? That actually may look cool.
Let's look at it.
So, but we should try to just make the one wavy wedge. So, okay, so let's switch to the computer.
Yeah, the other alternative was interactivity, but that sounds like a 2-hour episode.
I mean, I don't know what's going to happen here. This is a lot of question marks. I have an idea, and we can iterate. And if I already knew how to use an observable notebook, we could probably do this in an observable notebook. But observable notebooks are something I've only been meaning to learn forever and haven't actually used yet.
You couldn't do it. Observable notebook works on one JavaScript file. So we can't really, this is
What?
an Ember application. It has a
Oh no 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 no
million.
no 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 no. Sorry. No, what I mean is figuring out the code to draw a wedge.
Oh, separately.
Yeah,
Yeah,
yeah. Like we could do that in an observable notebook. But
yeah, just that little bit. Yeah.
yeah, but I don't want to waste people's time with me figuring out how observable notebooks work. And
Yeah.
I've looked a couple of times. Maybe for next week I'll create one for um so we can revisit this. So let me just because I will guaranteed
It's
forget.
your other show is from 3 to 5 also, right?
Correct, but I'm not
I'm
gonna
thinking of doing how to find from
ish
yeah,
ish.
how to find the ish 1 to 3, just so that for the fatigue effect. To what do you think? You
I
think
mean, I think well, it is the case that I almost fell asleep last on Tuesday during the show.
that's a sign? That is a sign.
Yeah, I was very tired, but it was the so like I haven't had a normal night of sleep in over a week. So like like it's just
It's COVID. No, nobody's had a normal anything
yeah, but there's like no normal and then there's a little normal.
like COVID normal.
Yeah,
Yeah.
yeah. I haven't even had COVID normal. All right, wavy wedge in observable. Sorry, I'm just creating an event for myself next week to remember to do this before the show next week, before the Rose Hall show next week. I know we don't work on this project while we are not in front of the camera, but learning how to do an observable notebook isn't working on the project. It's a way to
Correct.
make the process more transparent to you all down the line. It would be like
That is correct.
if we decided that we were going to start doing episodes of the show in Spanish, and I would be like, but I don't speak Spanish, and then first we had to have 3 years of the Rose Hall project with me just in Spanish class. No, I am allowed to
Observable
do.
notebooks, by the way, this is for the people watching who's never heard of this. It's like the Jupyter notebooks of JavaScript.
Yeah,
So if you never
especially
heard this before, it's like if you're familiar with Jupyter notebooks, which been around longer, this is like the JavaScript version of it, like where you can actually write JavaScript code and you can see the results right there, and it's kind of like a notebook. It's like,
yeah. So the notebook model, I think, owes a lot of its uh, history to Mathematica. I think Mathematica was the first um, application that really had this idea of code plus text, etc. But it blew up with the Jupyter Notebook, and then the person who created D3 went on to create these observable notebooks. So they are.
which, as you can imagine, is super handy in the D3 world because you can see the results of your visualization on the fly, but leave a record or trace of like what got you there. So if you look at these observable notebooks, they're not that very different from like the documentation you find on D3 examples in the first place. So if you Google D3 recipes, you will find a bunch of pages on GitHub of different kinds, and they're kind of like documentation. Aesthetically looks like these things.
Oh, well, actually, a lot of D3 tutorials now are just straight up observable notebooks. I want to point out here that this first staff pick here is about African American writers, and I wanted to shout out the fact that I missed this, I think, because of my other show. But let me. Um, they had a live stream about let me see. I don't want to spend too much time on this, on hunting this down, but they've had these 10 years of open source visualization, like the set of these live streams. And the most recent one was about like doing data visualizations on like black experience, on African American history, etc. Like partly probably tied in with Black History Month. Um,
I'll look for it later. Very cool. That's a
well,
good.
yeah. Let me. I might be able to find this rather quickly here. Observable HQ Black. Oh, that's not the man. I am tired. This isn't the Twitter search box. This is the Twitter search box. There we go. There we go. Black in Data Viz. That's what it was. It was a meetup, and it was 2 days ago. So I had this week has been too ridiculous to be able to do. But it would be cool to wrap around and have a look at this. So I hope you're sort of taking notes, Alex, and we can talk about this off camera a little bit.
Yeah,
To see.
absolutely.
I know that this is probably like right up Rupika's
Oh yeah.
alley. So, oakley dokley. So those are our observable notebooks. Uh, let's start a new window here. Oops. And there we go. Okay, so the way I thought that we could go about doing this today is to just have one wedge. So let's go to VI. Where does the data load? In the routes. In the index? Yes, here's the data. Okay, so yeah, sure, let's do this. So does this crash everything? Oh, there we go. So this looks like something from an 80s movie. Uh,
Or a logo on Fiverr.
oh yeah, that's what they look like.
That's a contemporary logo on Fiverr. You're not gonna get more than that for $5.
Oh, this is like I thought you meant like a Fiverr worker might have this as their logo.
Oh no 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 no.
Dude, getting this white thing in the middle here working to look like this definitely cost more than $5.
Good point.
Like, wasn't that 2 whole episodes?
Kinda, yeah. It carried over.
Yeah. All right, so we have the one person. Obviously, the problem is that the wedge is now a donut and not a wedge, so we have to go back. I don't feel like getting rid of this. This was the last thing we did last week. I'm gonna keep this here just because it's Friday. All right, so that loads the data. And this should be everything we need to know about this. So the start angle and the I would ask you, but then you'll get angry that I'm playing Socrates again. So the reason it's a whole donut here is because there's a start angle of 0 and then there's an end angle of 2 pi over 1, which is to say 2 pi, which is to say the entire diameter of a circle. So instead, let's make the end angle.
It can still be 2 pi. We just need something curvy to happen in between.
No, you won't even see it. Like, this is one wedge. So where are you going to see the curviness?
All right.
So we'll keep that as, and we'll just 10.
Do 5.
What?
Do 5.
It's just going to be fatter.
Oh, right, because it's the smaller. Yes, of course. This is a circle divided in 10
This
parts.
is fine. This is fine. Okay. So what we're doing is we're using this arc method. And what this actually gets us is it gets us this this thing here. So let's actually have a look at the code for this thing, okay? And actually try to figure it out. I sort of like yada yada'd it last week.
Mm-hmm.
But like, let's look concretely at. Come on, copy. So instead of all of this, let's have it just return this.
You're gonna have to have a better quotation mark game. There you go.
What? What's wrong with my quotation marks?
No, I thought the D had to be a part of it for a second.
No. Okay, so now this returns this wedge. So now no matter how many times I reload, the colors will change, but the wedge will stay the same.
Right.
I'm not entirely sure why the colors are changing this much, but I don't care. All right, so my goal here is to understand what is called the path mini language. I don't actually know what it's called, but in the tutorial that finally made me understand what this was all about, it was called the path mini language.
Well, let's go to the documentation.
Oh, dude, we're gonna do that. Don't worry. Still works? Yep. Okay. All right. So let me zoom in a little bit so you can see what's going on here, Alex. So this is the mini language. It makes up the D attribute. So there's an you have these different things. They have spaces, so these spaces are optional, but let's add them just for.
I also noticed that the M, the Q, and all this other stuff is not used all the time.
Correct.
Oh, it is there. Where's the Q?
We don't have a Q.
We had it in there.
So, what? path commands. There we go. All right. M, move to. So move to this point. So that's the first command, is move to this point.
Right.
Then
What is we moved?
the pen.
Right. Okay.
Move the pen to this point.
Okay.
So the fact that this is basically 200.
Right. Minus 200. That is out of 360, right?
No, these are XY coordinates.
Okay.
Do not think in terms of rotation or anything like that.
So minus 200 is in the y-axis, right?
Right.
So this is almost 1 on the x and 200 down.
But
xy is at the top, at the 0, 0.
0, 0 is in the top left, right. So minus 100, actually 200 goes up.
From the top.
From the top. So what I think is going on here is the pen is in the center of the diagram.
Correct.
And it goes up to the outer edge.
Give it 300 there, and if it goes down but stays more or less in the same place, that's how we know.
I can't really do that because it's going to turn the rest of this.
Anything that's 200, you turn it into 300.
All right.
That should do.
See. So yeah.
So it was the top tip.
No. So the pen starts.
No. Yeah.
So the pen. So the pen is at the center, but then
Right.
it doesn't draw to up there. It just moves to up there. M is moved, not draw, just move.
Right. Just move. Yeah.
Yeah. So then the next thing it does is it makes this arc. That's what the A is.
Right.
So
now it's drawing.
So now it's drawing, and let's see where's the A. Okay, it's this elliptical arc curve. So A is made up of an Rx, an Ry, an angle. Okay, so let's an Rx, an Ry, an angle. Oh, you know what? I think it is drawing a line here.
In the move?
Yeah, because think about this. This is building something that is
Erase everything else and just leave the M and see if it does anything.
Like just draw a line?
Yeah, just comment everything else just to see if the M is just doing something. It's not?
No. Okay. All right. I understand the my little conceptual hiccup here. Okay. So we gotta break this down and think of it as it's doing three things. And the funny it's actually doing four things. But we see it as three things. So the wedge is a triangle, right,
Mhm.
with a little arc in
Right.
between, right? So the first move here says move the pen up to where the arc begins, but don't draw. And I'll explain why this is the case later. Then all this A stuff here, this is draw that arc. These are the rules for drawing that arc. Okay?
Right.
And
It's
then
we just go to the
then
angle 300.
no, it's it's more complicated than that, and we'll get into that in a second. It's this whole stack of commands is
Right.
describing that arc, right? We'll worry about that in a second. I'm just explaining the structure. So move the pen up to the top.
Mm-hmm.
Then this is draw an arc,
Mm-hmm.
and then this LOO is from the end of the arc, draw a line to 0, 0.
Enter.
Okay? But that, you'll be like, well, that's just like this. That's not a full wedge. But that's why you have the Z at the end, because the Z command is the only one I ever remember. And Z is close the shape. So it draws the arc, then a straight line, and then draws a straight line from the end of that line to where the arc begins
To close the shape.
to close the shape. Yeah.
And 0 though here is the center, Monsieur.
The center. Yes.
So it's not an XY grid.
No, it
Well, it is. Everything can be an XY grid on a screen, but
actually that's a good question.
But the 0 here would indicate that it's actually considering the center of any circle as.
Oh no, it's sorry. It's not the center. It's because it's inside of a group. So I think that the coordinates are within a frame of reference within that group.
And the group is the one that created the circle in the first place, so that's why the 0 is there. Okay,
Yeah,
got it.
I think that's right. Yeah.
Got
So
it. That makes sense.
so one way of thinking about this, so one way of writing this, so what we know then is that this L00 is going to have to be turned into a wavy line. Let's see, does this crash? Nope, this works fine. So this
You can go
L0,
back to the 200 if you want.
this L00 is going to have to be replaced by a wavy line. And then we can't just move the pen here. We have to draw a wavy line.
Right.
So let's
imagine first let's look at the parts of a wavy line. It has 4 parts. Let's draw one.
well, hold on. It'll be easier than that. Just give a second here. So what we're really interested in here is
Has a
knowing
name.
what?
It has a name. It's called a Bezier curve.
No, this is not a Bezier curve.
No, not that one. The line has to be converted into a Bezier curve or 2.
Well, we're going. What I'm getting at is so okay. So this is what I was thinking about at the end of last week. Like I'll say concretely. I was trying to sort of show it, but so now that we understand that this wedge is made up of 3 drawing commands, where one of the commands is just close the shape, we need to replace it with our own 3 drawing commands. So what we need to do is we need to figure out how to get this point, how to get this point, how to draw this arc, and then how to make this wavy and this wavy. So my suggestion is that we replace this with yeah, let's. So my suggestion is replace this with L 0 minus 200.
You got to put the point somewhere, man.
L, what's that?
To start with, you got to put the point somewhere.
What point? So is this crashing? Okay. Okay. So this indicates the move from 0 to minus 200.
All right.
Then it draws a line to goes over 168 and then to minus 162. So these coordinates are in the frame of reference of the thing as a whole, not in the frame of reference of this point,
Right.
right? As we expect, that's normal. And this says go back to 0, 0, and then close the thing.
Right.
Okay. So,
we can go back to replacing the first L with an arc if we want to. I mean, we could leave it flat. It's gonna be
let's leave it flat for now because this is going to be a very complicated thing. So we need so build pedal needs to do a couple things. So first, it needs to know how tall to draw the wedge. Then know where to draw the end of the wedge. Then return to center. Then close shape. Right?
Mm-hmm.
Okay. So and then at the end, we'll do d equals d plus z to close the shape.
Mm-hmm.
And we know that return to center will be d equals d plus l space 0, 0. And then these two we have to calculate now. And so then here, instead of this confusing stuff, we can just do return this build pedal. Okay, so let's do how tall to draw the wedge. Let's do d equals, do you know off the top of your head now what to do here?
Yeah, 200.
Yeah.
Oh, you're gonna try to do them all at once? Okay.
No, well, you'll see. I'm breaking this up into pieces so that we can abstract every single one separately.
Okay.
Okay, so why did it error? This build pedal is not because it's a getter. Okay, so what did we do? What did I do wrong? Oh, I never probably returned D. Yeah. Whoops. Okay. These are supposed to be... Nope, that's positive, but this is minus. Okay. All right. Are you excited yet?
I think it's gonna happen. What did it actually? Okay.
All right. So how do we know how tall to draw the wedge?
We gave it an absolute value.
Here, yeah. But so let's start thinking about this in terms of
No, but we're still gonna have to give it an. Oh no, the age.
not the age.
The time I spent at the.
No. But close.
The time spent at the Rose Hall.
What is the top of the edge show?
1930. It's 1980. 12 to 32, or
No, the top of the wedge, the outer edge of the wedge. What does that show?
that you made it to the end of Rose Hall.
No, not the top of the graph. The top of a specific any wedge. What does that show?
You left Rose Hall.
At that time, right? So it is the top of the wedge is related to your Ashley just wrote. Did you mess with the logo turtle when you were a kid, or were you not sufficiently upper middle class? Yeah.
What's the logo turtle? Man, I had all the upper middle class toys. What is this?
Logo is a programming language where you used a little turtle and you drew pictures with him.
I did. I had a basic kind of childhood. My magazine that I subscribed to for my Commodore 64 had use basic or assembly. So you either type assembly directly or basic. I can't remember the name of the magazine. I think it was actually called Commodore 64.
Yeah, so we had in my computer class when I was in like first and second grade.
You fancy. You had computer class.
Yeah, see, yeah, you're all here like I grew up upper middle class. Dude, you
In
grew up
my
upper middle
house,
class in the Dominican. I grew up upper middle
the
class
high school education is based on Jesuit
in
education.
Massachusetts.
Where I bet you guys accepted in first grade as I did.
What's that?
That in Jesuit education, you actually, before you even do your first arithmetic addition, you have already covered all of set theory.
Yes, we did not do that.
You see, I was already doing intersections and unions and all this kind of stuff when I was 7 years old.
Yeah? Rad. Anyway, we had our little Apple IIes. Well, they weren't little, they were huge. And we learned how to do logo, which is, and so Ashley says this is mad logo vibes. And of course there is, because that's exactly what we're doing. We're moving a cursor around a predefined Cartesian space and telling the pen to go up or down and to draw things. These were literal commands you would tell the turtle. You would say like RT90 meant turn the turtle right 90 degrees. P up meant pen up, because then you would move a certain distance and you didn't want to draw a line. And then when you wanted to draw a line, you would do pen down and then you could turn them again. And so like my goal, to give you an idea of what was among the most important things in the world to me when I was in first and second grade, my goal was to draw Garfield in logo. And I never had time because we had like 10 minutes at the end of class where we could do whatever we wanted to do. Maybe it was like 5 minutes, I don't know. And I could never get past drawing the 2 circles for the eyes and the little circle for the nose.
I think I remember vaguely. It might be a false memory, but I have some kind of false memory about this kind of exercise in my childhood. Maybe it's just weird deja vu effect from fatigue or something.
Okay.
But what you're saying sounds familiar, or maybe I've seen just YouTube or representation of it.
So, anyway, so the top of the wedge shows the exit year of the person, right? So I'm going to play a little bit of Socrates here. What do we have to, like, how can we re-describe this first step in terms of the exit year?
We have those values already as variables elsewhere in the code. Let's go and get those variables and put them right
Do
there.
we?
We do.
Where?
Well, we have to convert them into wait, the scale. We have to set up the scale and set up the range, domain and range.
So outer radius. This line here, outer radius.
Yeah, there it
Okay.
is.
So,
Except I don't know if it's going to express it exactly in those values, but I think it is because that's what was producing them in the first place.
all right. So we have this arg's year scale, which I will remind you is, in case you don't remember, is a function that takes. Do you remember what it does?
It takes the data set.
It takes in a year and converts it into the scaled pixel.
Oh yeah, the year scale thing. Yeah.
Yeah. So we
Which
can
is
just
what we
say
need.
let
Version of one
top
measuring
Okay.
unit.
All right. So the top edge is whatever this is going to be, right?
Yeah.
That's correct. So, but yet we have like this gives us one number, but this first thing is two numbers.
Yeah.
So what do we do?
It's always going to be 0, no?
Yes. It will always be 0. So we actually only need the y coordinate here.
Yay! I passed the Socratic test.
Yay, you win.
Do I get some kind of pedagogical
You win.
Or...
No. So why is this wrong?
like I'm learning.
Yo.
I'm learning.
Yeah. Plato. Why is this wrong?
Foucault wasn't wrong. These are all. Oh my God! What is this? What the heck?
This is right.
Missing the minus sign.
Bingo.
Yay! I learned. You're gonna turn me into a Foucauldian by the time we're done here. He was right. This is all about discipline. This has nothing to do with learning. Nothing. It's disciplining my body.
Is it break time yet?
It's end time because
no, it's not an end time. Aren't you excited? Don't you think we can actually like get close to being finished with this by the end of the hour?
I think no, man. We got 5 minutes. We're not.
No, by the end of the show, like do the show the 2 hours.
Like next week?
No, we'll now you're not feeling a little bit of like I think we can do this.
You want to keep going until we do?
I want to keep going. Yeah, it also increases the chances.
The man woke up.
I didn't wake up, but I'm starting to conceptualize how to do this. And
then let's not forget. Let's we got to take advantage. You know, this is the kairotic time. This is kairos. This is a new kind of temporality, the opportune time. I think the Bible calls it the opportune hour.
The golden hour?
No, it's like, there's a time under heaven. It's this different notion of time. It's a time about when is the revolution ripe.
Why is it 25 degrees in my apartment? The heat is off and I have a fan going.
Let's do it.
All right, let's break, and then you're going to walk me through how to do the rest of this.
What? No,
you have everything you need here.
No, man. No. I'm going to go read Foucault. I'll be right back.
All right, we'll be back in 10 minutes.
Antidote for this nonsense. I'll be right back.
Alex, there he is. All right, excellent. Welcome back, Alex. How was your break?
It's good. I tweeted.
You tweeted?
Well,
What?
I DM.
Oh, that's not the same as tweeting.
No.
So, okay, so this is done. Next line. Do you have an idea what to do here?
You do?
Let me tell you what my ideas are, because they seem unnecessarily complicated. So,
My idea is just to follow the circle and draw a width,
but
max width formula.
what circle?
The imagined circle. If we have a center, we have a circle.
So, we have this right now, right? Where A is the very first A is equal to top. But we need to find this point.
Yeah, the other easy way to do this is to actually calculate the same distance. That just to copy and paste the same distance that is traversed for the first point.
So what we have is a right angle with the hypotenuse of A, which is top, right? So we need to know.
Yes, and what I am suggesting to you is that we come up with a fixed width that is
There is no fixed width.
Okay, if it's a triangle. All right, let me just draw it on a computer. Just give me the screen rights. Can I have screen rights?
I don't. I'm worried that if I do, you're gonna like do something bad.
I'm gonna actually pull up a triangle that has the letters A, B, and C, so I can tell you what I mean with letters. Or show me yours, and show me yours, and does it have letters? Give me A, B, and C.
No, it does. So I mean, I can explain what we need. So we have we have this new point, right? And we know A,
right?
And so we have here. Let's call this angle X and this angle Y. We have A and we have angle Y. If we have angle X, then we can solve for B and C with our good old friend trigonometry.
That's one way to do it. Go ahead and do it that way. I had another way of doing it that would produce exactly the same results.
Okay.
But go ahead and do it that way.
All right. So we know that. So how do we do this? So we need to. What is the angle width of the wedge? Do you know off the top of your head? Because we said it.
The first line is the first angle is like
2 pi 10, over 10.
10.
2 pi
yeah,
over 10.
it's one. It's but basically just a pizza pie divided in 10 pieces, and this is 1 pie.
Hold on a sec. Where is that? Okay. What is the angle width of the wedge? is 2 pi divided by 10. Okay? So in other words, that's going to end up being 2 pi divided by number of people, right? Eventually, when we turn it into into math. So let's grab what that looks like. Okay. Now, the angle we need is equal to pi over 2 minus wedge width, right? Pi over 2 is 90 degrees.
You can try it.
No, we're far away from drawing something. So const angle is equal to math dot pi divided by 2 minus the wedge width. So const wedge width equals, math times pi divided by 5. We can do a little bit of reducing here. So the const angle is math dot pi over 2 minus
Wedge.
What's that?
Wedge width. Dollar sign wedge width.
Yeah. Well, no dollar sign, but yes. Okay. So now that we have the angle and we have the hypotenuse, how do we get the two legs of the triangle? Tangent.
This is your method, girl.
Dude, I haven't done trig in 30 years. I'm trying to remember this. So
I wasn't taking the trig approach. You're the one who wanted to take the trig approach and work this through the angles. I was working it through the sides. I would have worked it through the sides, not the angles.
What sides?
A triangle has 3 sides.
Right.
Forget about the angles for a second.
This is going to be good.
There is a triangle only has 3 sides. If you have 2 sides already, and one of the sides is always a tangent to a circle, meaning the outside one, and you have a width number that you already know what it is, you don't have to do the angle.
What any side of a triangle is tangent to a circle. What do you mean?
You see that if the top side there, let's call it B. Let's call the one that you have on the screen. Let's call A the one further to the left, B the one on the top, and C the one here, the hypotenuse here, in this particular work. Right now it's at a 90 angle.
You mean like
But
this?
what we need it to be, what we need that, is that say A, B, and C? Yes.
Yeah.
So
that B is not tangent. B is a chord.
A chord, yes. B should always be a chord of the circle.
Right.
So we know the angle of B always. It has to be a chord.
But how? Well, we know the angle of B because we know that's wedge width. Is the angle, is this angle. That's the same thing that we've already calculated.
Right. So what I'm telling you is the length of it, the actual amount of pixels in the line itself, forget the angle for a second, should be always fixed, a fixed number. That means that line is always going to end up in a predetermined point.
So let's assume that this wedge is 200. So we have a circle with a radius of 200, right? So you're saying that if you have an isosceles triangle that's
It wouldn't be
200.
isosceles. That's the
No, but
thing.
it is. It's 200 by 200.
Oh yeah, it's isosceles. Sorry, not straight. Yeah, sorry. Because what you have right now is a straight angle. It's
You're
a
saying
straight.
that if you can get the length of B based on an isosceles
You
triangle.
don't need to calculate the length of B. You need to just assign it a value and call it a day.
I don't understand what you mean assign it a value.
Okay, imagine there's 200 people in Rose Hall. That means there's 200 wedges. That means whatever a circle divided by 200 produces.
Right, that's the angle. That's not B. That's not the length of B.
That's the length of B.
No, it isn't.
Yes, it is.
No, because the length of B depends on how long the wedge is, how tall the wedge is. The height of the wedge is variable.
So let me rephrase this in terms of the size of the circle. Given a full wedge, at the top, you calculate that width. And that is literally how the whole thing will be divided, except for the part, of course, that D3 does this weird thing where it tries to find the best fitting.
Don't blame D3 for any of this.
No, because we saw that last week. We saw last week that it will actually draw different widths for the wedges based on some kind of best fit.
We'll worry about that later.
Right, exactly. We're not worrying about that right now. So that means that we can actually come up with a fixed number for the
idea that this number is fixed
all the way to the end. Even if it doesn't draw all the way to the end is still implied as a fixed width.
I don't know how you do this without trig.
All right, let's do it with trig then. You're probably right that we need to do a trig because how would you calculate if a wedge doesn't go all the way to the end because the data the person left?
No. Well, all Alex, all that means is that for every person, the circle has a different radius because the exit year is different, right?
I get that part. And what I was saying is that we actually draw everybody first as if it was a full wedge.
And then cheat back?
And sculpt back.
Okay.
Because I found that in my head to be the easiest way to calculate this, rather than doing the trick so that everything is calculated on the fly according to the first line. But look, trig is not that hard to.
No, it isn't, and especially since hold on. Especially since this is even easier, because the angle that we already have, that we have for the wedge, y, is the same as this angle.
Correct.
Because these three angles have to add up to 180. So we have the tangent needs the opposite and the adjacent all right, so now let's do trig get opposite and what's that?
No, that's it was unavoidable. Let's get the opposite angle.
All right, so when we have the hypotenuse, no, but this is, what do we do if we just have the angles?
We have more than the angle. We already have one. We
only have the hypotenuse, and we have an angle.
Right. Well, there's no hypotenuse because we're not going to end up drawing straight angles. This is where it also gets complicated because
No, we are drawing straight angles.
we're drawing isosceles. It's not straight.
No. But it becomes a right triangle because we're calculating these coordinates. So it's going to be the x value and the y value make up a right triangle.
Not in the end.
Yeah, in the end.
No, man.
Yes.
That would not make that last little wedge side into a chord. That would make it into some weird angled stuff. It would look ragged, edged.
All right.
Here, let me. I wish I could draw this. Imagine if we ended up doing right angles for everything. Everything will have a little point. That's not bad, but it's not the.
No, dude, I'll show you what I mean.
All right. Can we go back to reading, anti-colonial poetry? It's easier.
All right, so let's make a circle first, and let's do everything be hundreds. Okay, be 100. Okay, so the person we have spent 100 pixels worth of time at Rose Hall, right? So we have a line. Well, let's just do this way. So we have a line that begins in the center. Why are you pestering me? Shoot. So we have a line that begins in the center and then just goes straight up, right?
Right.
So it's actually 50. So then let's change this then to 200. Okay. Zoom out a little bit. So this line is 100 tall, right? And we know that at, the wedge ends somewhere. So let's copy this line and just tilt it a certain amount and bring it back here, right?
Yeah.
So we need to find this. This coordinate is what we need, right? So
No, hold on a second, because I want, before we move on to anything else, I want to show you that we're not working with straight angles. Can you connect those two dots at the top with a line? Okay, that's not a straight triangle.
Do you mean a right triangle?
A right triangle, yeah.
Yeah, I never said
That's
it was. This is an isosceles triangle.
And I saw, that's what I was saying. It's not a. There's
yes,
not.
But now hold on a second.
Yeah.
If we go like this,
Sure, if you make 4 slices, there's, yes, then we finally have a straight triangle.
This is a right triangle.
Correct.
And this value is the x value for this point, and the length of this is the y value for this point.
Correct.
So given that we know this, and given that we know this angle and this angle, if we can calculate to get these two, then we'll know how to get this point.
Oh, sure, yeah.
Right. So I just can't remember how to calculate how to get the opposite and the adjacent when you only have.
It's one of those things where of the learning Spanish behind the scenes. I think we're
Catoa.
allowed to actually learn Spanish behind the scenes here. In this case, this week, we're allowed to learn Spanish behind the scenes.
Well, I think we'll figure this out in a second here. Right triangle calculator. Okay. So, because I had to do this rather recently, actually. All right. So, Why did I have to do this? I can't remember now why, but I had to do this. So C, we know. Let's say C is 200, right? And
Yeah.
we know that the that this angle. Let's do it in degrees. 60, and then that means that this one is necessarily 30. So there can only be one triangle that has 60, 30, and this is 200. There's only one such right triangle, right?
Right.
Oh, yeah, sorry, with this. So, all right, given C equals 200 and A equals 60, A is equal. Why aren't you telling me the math?
Man, what?
All right, let's change this from 60. Let's do something a little bit less.
They invented, my teachers were right. They were like, those calculators are going to ruin your mathematical thinking.
Okay. Sine theta. Okay. So we have to do two calculations, because in sine theta equals opposite over hypotenuse, we know theta and we know the hypotenuse. So we do
Right.
that to calculate for the opposite, and
just
then
just multiply the sine and the hypothesis, and we'll get the other one.
or we can just take the cosine.
Let me
But
see. I just didn't divide it.
sorry, you can't really see here.
Sorry. Okay. Yeah.
Okay, so now how JavaScript trig functions.
We're bringing a package.
All right, the sine method. Da, 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 da.
Oh, this is easy. Math.cos.
But is it okay? Math.pi. So it is in radians. Okay, I figured it would be. All right. So we have theta in radians, and then so we know that const x is equal to so this is theta here.
Mm-hmm. Man, I know it. You don't have to draw.
Okay, all right. So this is theta here. So we have theta. So x is the opposite. So that's opposite OH. So that's sine. So x is equal to math sine the angle. What's the angle? Wedge width. So sine equals opposite over hypotenuse. So it's hypotenuse times the sine equals the opposite. So okay. So times top, right?
Yeah.
And const y is equal to is hypotenuse math cosine wedge width times top. Right?
Yeah.
And so now we should be able to do x and y.
Why?
Excuse me. That should work. Math!
Good job.
And so this is what you were talking about we always know the circle, so we can always cheat back. So this does it for us. So we can probably just look at the D3 code to figure out how to do this part, and like we can worry about that a little bit later.
Let's do the curve.
You want to do the? I wanted to do the wavy lines next.
Wavy lines, yeah.
Oh, okay. So, see, like, oh, so actually, they may even have a circular arc segment with a specified radius that starts tangent to the line between the current point. Yeah. So we could just use the arc2 here, probably to get that. But these aren't. I want the rad lines. I don't want these boring paths. I think it's D3 shape. Okay. So here are where the lines get rad. So these lines are these are describing how you draw lines between a certain number of data points. Whereas we just want like to draw like a sine wave probably, right?
Yeah.
Don't look at the screen. It'll put you to sleep. Ooh. Ooh. Pretty. All right. So the suggestion here is not to use D3 to draw a sine wave.
Google Bezier curves. Sorry, what was that? So I have myself checked.
You can't just do Bezier curves because you don't know what the control points are. Like that may end up
that thing by 4 parts, 4 chunks, and do 4 super, predictable Bezier curves, connecting each one of those points and call it a day. I could draw it for you if I had Illustrator share my screen right now, but it looks more or less like an S, like the letter S.
You have Bezier curves are part of the path thing. So let's see.
Exactly. Do a quadratic one with 4 parts. Here, look at that. Pretty, beautiful.
Right.
That's the one.
Yeah.
That's not it. That's not the quadratic one. That's the other one. Let's look at the quadratic one. Go down. Let me see the quadratic one. Yeah, quadratic and yes.
But you see the problem?
That has 8 points. 1, 2, 3, 4, 5, 6, 7, 8. Okay, do half of that.
Let me see what these values are because this may help
Yeah,
solve the thing.
yeah.
So draw a quadratic Bezier curve from the current point to the end point specified by xy. The control point is specified by x1, y1. So from the current point, 1050 to 2525. But then how does this get this many lines? They don't do it again. Implicit repetition is what I want to know about. So what is t? So what if we do okay, so well, this doesn't look like much.
Not yet, not yet, not yet.
So we want to use this cube, but this wants a control point. But how do we put in the control point?
Divide the line by 8.
Well, so here they have 4050. So start at 1050. Okay,
Look, create a variable called control point. Okay. And let's do the following calculation. You said you wanted the things to overlap, right?
no,
That you
don't even. We just want a curvy line.
Well, I'm trying to predict already ahead.
No, don't predict ahead. I guarantee you that's too much work.
Okay, fine, fine. I already know what's going. I have amazing powers of prediction, but that's fine. Take the length of A, side A, according to our Platonic triangle that we drew already. Take the length of that line divided by 8.
Wait. This has a curve.
Yay! Except we need the control points to actually be a lot more compact. So, but yes, that does have a curve. Look at it. Actually, I like that curve. Very subtle. Very subtle.
It's we need to get a little bit more goofy here.
A little bit, just a little bit more radical there.
There we go.
Okay.
Right, so
Okay.
now, they have a initial control point at 25, and then there's this 30, 30, 30, 30. So let's just write that in because who on earth knows? All right. Chaos. Okay. So we need the problem here is because we're already drawing a line that's um on an angle, like they have the luck here of drawing just a 180 degree, like, a 180 degree thing. You know what I mean?
Mm-hmm.
And like along the x-axis. So they have it's easier to do these calculations. So the reason R30 30 is like this goofiness is because it's drawing along this whole thing, and it's a mess. So we need to calculate the control point along. So let me bring the Illustrator picture back. We need to calculate a control point that's somewhere in this space.
Yeah.
Okay, how do you want to describe that?
I wanted to do it by division.
Well, that's one way to do this. So we know this is 200 long. So if we put a center point in here, then we have the x value for the control point, and then we can do a perpendicular like that as the control point.
Yeah, that could work.
Okay. So
And if I'm not mistaken, that line is parallel to the. No, it's not.
No.
It's not parallel.
No.
Well, it's not hard to create because it's a 90 degree. You can just create a 90 degree.
Right. So how do we get this point? So we know that the is this just half x and half y?
Yeah.
That can't be right. Is it?
Try it.
Looking good. All right, so it's just half x, half y. Good to know. So we have this. Then, do we know what angle this is?
I was declaring it a 90 angle no matter what.
No, this is a 90-degree angle for sure. But this angle here, to get this point.
Oh, that one, no, I don't know what that one is.
So, well, we do know what it is because if we draw this out, this is another right triangle, and we know this angle already. So this angle, okay, well, actually, even easier, this angle is equal to the wedge width angle. It's the same thing. So what we need to do is we need to find the, we need to do like we need to find the linear equation that's the negative angle wedge width is as the slope.
Yeah.
And but we can't use a linear equation because the angle is, it's not given as a slope. It's not given as a rise over run. It's given as a radian. Oh, but we know this distance, right? And we know how long we want this to be. And so if we have the, well, we know this distance, and we know this distance. So if we have the, and then we just have to solve for this.
The hypotenuse
theta.
is easy to calculate.
No, well, we don't need the, we don't want the hypotenuse here.
But I'm saying once we calculate the hypotenuse, then we can calculate what that is really easy.
No, but what do you mean? How do we okay, so we know how to calculate the, but we don't need, what does getting the hypotenuse get us? To do this calculation again?
We can do the sine of the hypotenuse.
To do this
we can
again?
do the sine of the hypotenuse and it will give. Okay, all right.
Like I think
keep reasoning.
I think what you're saying is that if we calculate this length, then we can do this to get the y value and this to get the x value. I'm saying we don't need to do that because we know this and we know this, so we can use we know this length, and if we have the opposite and the adjacent, we can solve for the tangent of theta. And once we know what this theta is, no, I don't like it. I like your hypotenuse suggestion more. Okay. So, is equal to, so mid x is equal to x over 2. Mid y is equal to y over 2. So this gets us to this point. I don't know, it's not even on the computer anymore, on the screen anymore. So this gets us to here. Sorry. Then we know how long we want this to be. Let's just say let's just call it 50 for now. So we know that this is 50, and we know that this is 100,
Mm-hmm.
right? So then control hypotenuse is equal to
It's
math.
4:51. I just looked at the clock. Good try though.
I mean, I'm probably overdoing it with these parentheses, but whatever.
Never hurts.
So that's the length of this, and then we still need to calculate this angle.
I mean, that's the same angle as its opposite.
No, it looks like it is, but I think that's the dumb luck of the drawing.
Oh, okay.
So we need um,
My brain is officially fried. I tried to think a thought, but couldn't. My tongue keeps running after my brain stops.
opposite over adjacent. So that's a tan is the opposite is control length, and the adjacent is the top. Problem is, we're not really going to be able to test this, I don't think.
No, but if I were you, I have 5 minutes to leave some really good documentation so we know what the heck was happening last week.
Hold on. I think I almost got this.
Famous last words.
All right. So we have this last theta, last x times this, which is what I'm calling control hypo. Yeah. So ideally, we'll get something that looks like this. Like a nice gentle curve that's even across the length of the line.
That might work.
Do you think? I mean, that's what we're hoping for. Nothing seems to have crashed.
Yeah,
Hard
subtle. We can
hard
make it
hard to tell.
very subtle right now.
Okay, so let's make this bigger.
Yay!
Is that doing what we want it to do?
Do minus. No. Do 100, I guess.
No, this isn't evenly distributed.
What is it doing? Doing something that is not what we thought it was going to do. Can we do this? We need to do. You remember what we did in the beginning, where we broke down the arc thing into all the different parts? We need to do one curve, and we need to break that just one line, not even a wedge. Not forget wedges and all that stuff. Let's draw one line and make it curvy next week, and let's look at the parts. Yeah. Save that image, I guess.
Well, hold on a sec.
You have a 5 o'clock.
I can be late. It's a party. Oh, some of your faves will be there.
Who's there?
It's for the UCLA thing that Kelly Kreitz invited me to.
No.
The for the um what's it called? I'm here blasting my email on the stream. Uh, it's a workshop for doing like Latino mapping and stuff.
Hmm.
So like Marisa Lopez, Kelly Kreitz, they're the two organizers. Um, Sylvia will be there at the thing. I don't know if she's coming tonight. I feel like Moncho's not involved in this too.
Nice, nice. Good people.
Todd Pressner. I don't know him, but I know who he is. Yeah. So we're gonna be getting Tor and planning out the
Nice.
agenda. I mean, I won't be getting Tor, but whatever. All right, let me finish writing this. This is the hypotenuse of the triangle going from the perpendicular bisector's endpoint to the center of the circle. This is the angle of the mini right triangle made up of half of the wedge length and the perpendicular bisector. Y values of the bisector endpoint. Alex, as always, a pleasure to make my brain hurt with you.
I will be there next week to continue the pain.
So next week I'll be doing some work outside of school with Observable, so we can do this in Observable, hopefully. Maybe.
Sweet. That should make it quicker to test.
Yeah, because the problem with testing this is we're not really drawing the control lines in any way, so we don't even see what's going on. Ashley said it flipped over, and yeah, but why did it flip over? It shouldn't be doing that. So we don't know. So many questions.
I like it. Now it's starting to sound like the humanities. More questions than answers.
Yeah.
All right. I'll see you next week. Have a good weekend and enjoy your 5 o'clock thingy.
All right. Party on, Wayne.
Party on, guys.
Ciao, everybody. Thanks for tuning in.